Hello, welcome to Theory of Computations. The formal definition of finite automata is it can be represented by phi tuple q sigma delta q0 and f, where q is the finite non-empty set of states represented by q0 to qn. Sigma is the finite non-empty set of symbols called as alphabets. It may be represented by characters like a to z or digits like 0 to 9. Delta is the transition function which maps the current state and current input into the next state. Q0 is the initial state from where any input is processed. Q0 must belong to the finite non-empty set of states that represented by capital Q. Then capital F is the set of final states. We may have one or more than one final states in the finite automata, and therefore capital F is a subset of capital Q. The finite automata can be represented by a transition system. To create or design a transition system, we have to follow the concepts of graph or tree. So transition system has different number of nodes and different number of edges. There is one node which is called as a initial state from where we have to start the processing of our string. And how to identify this final initial state? The initial state is represented by an empty arrow coming to the state. Final state or accepting states are indicated by double circles. The notations used in this transition system are the notation used for start state and notation used for final state. So if it is a start state, then we can represent it by an incoming arrow to the state, and if it is a final state, it can be represented by double circles. The example of transition diagram is like this. See, in this example we have different states like A, B, C and D. Among these, A is the initial state since we have an empty arrow to A. D is a final state because it is double circled, and the transition diagram can process the input symbols like 0 and 1. Now see what is acceptability of a string by finite automata. A string W is acceptable by finite automata M, which is represented by phi tuple q sigma delta q0 and f, if and only if the transition function q0, that is start state, after processing all the input alphabets given in the string, transit to a state q for some q which belongs to the final state. This is actually called as acceptability by final state, and the final state is also called as accepting state. Now see the how to convert transition diagram into transition table. For that, consider this transition diagram. First step is to identify the initial and final state. So in this diagram, the initial and final states are q0 only. To convert the given transition diagram into transition table, we have to start with the table with two different columns. In first column, we will have this present states, and in next column we will have next states. After this, we have to write down the inputs, whatever it is going to process. So as you can see in the transition diagram, it can process only 0 and 1 input alphabets. Now draw the table. So for that, first you need to write down whatever different input states are there, just put down that into the present state. So first is q0, then q1 state, then q2 and q3 state. Like these are all the states which are present in this transition table. Next we have to fill up the next state column. So if q0 is the current state and input provided is 0, then it is going to state q2. Therefore we will write in this column state q2. q0 with input 0 is transiting to q2. Then if it is q1 state, q1 with input 0 is transiting to q3, q2 with q0 Q2 with 0 is transiting to Q0, Q3 with 0 is transiting to Q1. Repeat the same thing for input alphabet 1. So if it is Q0 state and if it is Q0 state and the input to be processed is 1, then it is transiting to the state Q1. Therefore, we will put Q1 over there. We have to repeat this for all the states. So Q1 with input 1 is transiting to Q0, Q2 with input 1 is transiting to Q3, and Q3 with input 1 is transiting to Q2. So this is how we can convert the transition diagram into transition table.